Imagine standing in the African grasslands 60,000 years ago. You are carrying a bow, but your arrows are tiny. Their stone tips are only a few centimeters long. They are sharp enough to cut skin, but not powerful enough to bring down a large animal immediately. You release an arrow. It strikes an antelope, leaving what appears to be a minor wound. The animal runs. You do not chase it at full speed. You simply follow. Hours later, its muscles weaken. Its movement slows. And eventually, it can no longer escape. The arrow did not kill the animal alone. Something invisible on its tip finished the hunt. For decades, archaeologists suspected that prehistoric hunters may have used plant poisons. But suspicion is not proof. Poison normally decays. After thousands of years underground, almost nothing should remain. Then, researchers examined 10 tiny quartz weapon tips from Umhlatuzana Rock Shelter in KwaZulu-Natal, South Africa. The sediment surrounding them had been dated to approximately 60,000 years ago. On 5 of those stone points, chemical analysis detected 2 toxic alkaloids, bufandrin and epibufenazine. Both substances come from poisonous plants belonging to the Amaryllis family. The most likely source was Buphone disticha, a toxic bulb native to southern Africa. This was not simply a sharp stone. It was part of a biochemical weapon, and it is currently the earliest direct chemical evidence of poison being deliberately applied to prehistoric hunting weapons. The discovery changes the question. It is no longer whether ancient humans understood poison. They clearly did. The real mystery is how they discovered it. A poisonous bulb does not explain what it can do. It carries no warning label. To turn it into a hunting weapon, someone first had to recognize the plant, extract its toxic material, apply it without poisoning themselves, and understand that its effect might take time. That required more than luck. It required observation, memory, planning, and knowledge passed from one person to another. But the first experiment may have begun with a terrible mistake. Perhaps someone ate the wrong bulb. Perhaps they watched an animal weaken after chewing one. Or perhaps they noticed that certain insects, snakes, and plants could disable prey without tearing it apart. We cannot know the exact moment. Archaeology preserves tools. It rarely preserves the first idea behind them. But later evidence shows that poison-making became far more deliberate. Around 7,000 years ago, people using Kruger Cave in South Africa stored a dark substance inside the hollow thigh bone of a large antelope. 3 small bone arrowheads were embedded inside it. When researchers analyzed the residue, they detected several plant-derived toxins. 2 of them were digitoxin and strophanthodin. Both interfere with the heart. The compounds do not naturally occur together in one plant. That means the poison was probably a recipe. Different ingredients had been selected, collected, and combined for a specific effect. Some may even have come from plants growing far from the cave. This was not a hunter rubbing a random leaf onto an arrow. It was controlled preparation, and the goal was not always to kill instantly. A poisoned arrow could be extremely small. It only needed to break the skin and deliver the mixture into the animal's body. The hunter could then remain farther away from dangerous prey. A wounded antelope might run for kilometers. A larger animal could take hours, or even longer, to weaken. So the weapon depended on another prehistoric skill: tracking. Hunters had to read crushed grass, broken branches, hoof prints, blood traces, and changes in an animal's movement. They also had to remember the dose. Too little poison, and the animal escaped. Too much could waste a limited ingredient. A badly prepared mixture might lose its strength, and careless handling could injure the hunter instead. This knowledge could not survive through instinct alone. Someone had to teach which bulb to collect, which part to avoid touching, how to crush it, how long to wait, and how to follow an animal that might disappear beyond the horizon. The answer depended on the poison. In many later hunting traditions, the toxin entered through the wound and spread through the bloodstream. It did not necessarily make the entire animal poisonous. Hunters could remove the arrow, cut away the flesh surrounding the wound, and prepare the remaining meat carefully. But this was not a universal rule. Different plants and animals produced different toxins. A method that was safe for one poison could be dangerous for another. So prehistoric hunters needed more than a recipe for killing. They needed rules for handling the animal afterward. Where had the arrow entered? How much tissue should be removed? Which organs should be avoided? And how long could the meat remain usable? Archaeology cannot recover most of those instructions. They were spoken knowledge, passed from experienced hunters to younger members of the group. One forgotten step could mean losing the meat, or poisoning the people who depended on it. And that reveals why the discovery of poison mattered so much. A poisoned arrow was not one invention. It was a complete system. It required knowledge of plants, knowledge of animal bodies, control of dosage, safe storage, accurate shooting, patient tracking, careful butchery, and teaching. The stone point found by archaeologists is only the smallest surviving part of that system. Most of the technology existed in human memory. At Umhlatuzana Rock Shelter, chemical traces survived for roughly 60,000 years. At Kruger Cave, a multi-ingredient poison recipe survived inside a hollow bone for around 7,000 years. Together, these discoveries show that prehistoric hunters were not simply throwing sharpened stones and hoping for success. They were observing cause and effect, testing materials, combining ingredients, planning hours, or perhaps days, ahead, and preserving successful knowledge across generations. We may never know who first discovered poison. Perhaps it began with a sick animal, perhaps with an accidental taste, or perhaps with a death no one understood at first. But someone remembered what happened. Someone repeated the observation. And eventually, someone placed that invisible power onto the tip of an arrow. The weapon was tiny. The idea behind it was enormous. And 60,000 years later, a trace of that idea was still waiting underground.